Efrat Avnet Steinberg, co-founder and CEO of Inner. Thank you so much for being here today.
Thank you.
Let's start with what you do. You focus on batteries or a technology to enhance batteries. Tell us, what is the problem with batteries that you are trying to solve?
We focus on electric vehicle battery packs. We're talking about a huge object of 500 kilos, 2 meters long, really holding your car around it. And there's a huge quality problem in batteries. They deteriorate over time, they break, there's a lot of electrical, mechanical, chemical challenges there. And nobody really uses X-ray to look inside of it once it's already built. So we really picked up this challenge and built a CT machine that's big enough to scan it within minutes, to look for any types of crack, swelling, leakage, any kind of quality problem that will lead to failure or even to safety events.
Yeah. There are a number of companies that are looking into battery safety or I guess regulating or putting safeguards for batteries. What are you doing that's different from other companies?
Yeah, so there are two major differences. One is many times when they are using X-ray, which is for decades been the best way to look inside matter. So when they're using X-ray, usually they would focus on a cell, where a cell is the size of my finger. And of course, a battery pack is using thousands of those. So this is a major difference between us and other imaging solutions. On the other hand, there's a lot of battery management systems that use sensors, very clever sensors to monitor the health and the safety in a battery pack, but they're really waiting for symptoms, meaning when a battery gets hot or there's a gas emitted in the battery pack, they will know about it. But we are going to be there longer before that. When a crack appears, when a leakage appears, when a swelling starts to happen, usually it's going to be much longer before heat is generated. So we're going to discover it long before the BMS would. So those are like two of the major differences.
Okay, help me understand. Are you using technology that's already in existence and using it in a different way? Or have you created something that is new and being used to safeguard these batteries?
Okay, so we're using good old X-ray that's been there for decades, but in a completely different way. We build the solution end to end using our own patented hardware that enables us to build an X-ray detector that big, really to fit the dimensions of the battery pack, which is 500 kilo, 2 meters long. So that's one aspect. The second aspect is we're doing something completely different when it comes to pattern recognition, using machine learning to really recognize anything in the battery that's not normal. So we're looking for abnormalities, for anomalies in the structure of the cells, between the cells, the wiring between the cells, and we're doing this real time. So the processing is going to take minutes, meaning terabytes of data, giving the user really real-time diagnostics.
So how does it work? I put your scanner on the battery, or is it always part of, say it's an EV, it's always going to be part of the EV?
No, so it's, of course, X-ray is using a lot of radiation. So we're not going to use it constantly while we are next to it. What we're doing is the battery, there are two scenarios. The battery is removed from the car or the battery is still part of the car. We support those two. But in order to repair a battery, if something goes wrong, anyway, you remove it from the car. So once the battery is removed from the car, you put it inside a big box, which is our scanner, which is the size of a 20-foot container.
Okay.
Yes,
all right.
And then of course you close it. Yes, it's a size of a 20-foot container. The battery is put inside of it. You close it well because it's covered with lead, and then you press a button and you get a report. We're not in the business of producing beautiful images. It's not interesting for the users at all. But our software is going to analyze automatically the images that we produce with the X-ray and then give you a report telling you that we found a huge crack in cell number this and this, or a swelling in module number this and this, and then give you the ability to repair it very quickly and very efficiently. And then there's the second form where you're going to buy a 5-year-old EV and you want to make sure it's safe for your family to drive in this car. So you would take it to a garage that would have our second type of scanner. drive inside of it, step outside, close the door, press a button, and get a report. And then we tell you, yeah, it's a good car, you can purchase it, and it's safe for your family to drive in it. So there are a few scenarios there where the battery is inside the car or outside the car, yeah.
Now, you've said a challenging part during your R&D period was building the AI software that analyzes and scans the EV batteries. Now, can you tell us why that was so challenging and what the takeaway would be if there's a larger takeaway for other companies, perhaps not necessarily doing exactly what you're doing, but when they're looking to build AI into their process?
Yeah. So first of all, we're the first ones to do it, actually. Again, because we want to be sort of a commodity approach to really enable scaling in this market. So to support companies that have a huge volume of battery packs that they process. For instance, in production, in pack assembly, or also if you're a recycler that's going to recycle EV packs. So we needed to be quick. In order to be quick, you need to make sure that the analysis is very, very quick and very, very efficient, because we don't want to slow our customers down. We don't want to create bottlenecks. We want to help them be quicker. This is why machine learning, anomaly detection, AI, for this matter, was so critical. So our software is going to look for anything that's out of the normal, because every single pack from a specific module is going to be exactly the same. They're using exactly the same cells, and the structure, the architecture should be exactly the same. So anything that's different than that is abnormal by definition. So this is why it's so important, so critical to do it like this.
So in that case, given what you know now, what is your vision for electric vehicles 5 years from now?
Yeah. So we want every single battery pack to be scanned with X-ray, with our machines, multiple times along their life to make sure we maintain high quality, that there are no failures, and if there are failures, we're going to repair them on time before they create a problem, before there's a thermal runaway event like the ones that we've seen in the last summer, for instance, in Korea. We saw that there were major incidents. So if we scan a battery pack along its life, upon pack assembly, after a few years, before we take a decision of end of life, removing it from the car, before we use it for stationary application, before we recycle it, then we make sure that the quality is maintained, and also we make sure that batteries are used for much longer, because today we see that they're recycled too early, so more like after 7 or 8 years after production. And this is such a shame. They're so expensive, they're using scarce material. So according to our vision, they're used for 20 years maybe.
So at the moment there's a race for electric vehicles, but also for these fast charging batteries. I mean, we're seeing these prototypes that are coming out, that batteries that can be charged in 5 minutes. What are your concerns around that?
Yeah. So a few things. First of all, for existing batteries, it's not that healthy to charge that quickly. So of course, it just creates another reason why diagnostics should be improved. But it also shows indeed that there's a race, that the cell producers and the battery producers are all the time, they need to innovate and they need to meet demand and be creative. It creates a huge variety in the market. There are so many cell chemistries, cell formations, and we're actually completely agnostic for it, because we perform diagnostics for all of them. We support, our system and our software is going to support diagnostics in every single one of those types. So whether it's an existing chemistry or solid state, when this is going to be the next thing. So from our perspective, we're going to help every single one of those players.
So your current technology will be applicable to the next generation technology of batteries?
Exactly in the same way.
Okay. You touched on it briefly about sustainability.
Yes.
Would you say there's still a world where we can get green technology, or we can enhance our green technology through optimization, AI and big data?
Yeah, 100%. And this is what we're trying to do actually, because if we are making sure that batteries are used longer, for much longer, then and this is exactly what is a major part of our vision through better diagnostics, then we help exactly that same vision. Yeah.
What brings you here to Taiwan?
We were very curious to see what kind of synergies we can find here. There's so much knowledge here, and specifically around industrialization of solutions. So of course, if we want to go big and to produce massively and be everywhere and be this kind of commodity approach in imaging, which is exactly what we want to be, then we have to be here. The second thing, of course, this is our gateway to Asia, and specifically to this region where so much is happening in automotive. And it actually proved right, because the kind of conversations that we're having in the last few days are very promising, are showing us that we're at the right location.
Speaking of location, you built your company in Eindhoven.
Yes.
Which is home of ASML, NXP, and Philips.
Yes.
What is it about there that can be a takeaway for Taiwan about how they're always going in the next level technology?
I think it's a very interesting question, but you know, the Netherlands is not a big country. Yeah, but still having everything focused in a small region makes it easy to recruit the right people and also to enjoy the experience of the veterans of the industry as well. So I think we've seen it, and I live in Amsterdam, which is only an hour and a half away. So you would think, yeah, but actually the difference is huge, and everything around deep tech and hardware is focused in Eindhoven, in Philipstown, like we call it. So so I think maybe a takeaway for that is having this kind of concentration of brain and industry in a specific topic in the same small region makes it much easier for small companies to grow.
I think Taiwan is trying to emulate that.
Yes.
Thank you so much. It was great to speak to you.